Toner is a powder used in laser printers and photocopiers to form the printed text and images on the paper, in general with a toner cartridge. In its early form it was a mix of carbon powder and iron oxide. Then, to improve the quality of the printout, the carbon was mixed with a polymer. Toner particles are melted by the heat of the fuser, and are thus bonded to the paper. In earlier machines, this low-cost carbon toner was poured by the user from a bottle into a reservoir in the machine. Current machines feed directly from a sealed laser toner cartridge. Modern laser toner cartridge is intended for use in color copiers and printers come in cyan, magenta, yellow and black. Composition, size and manufacture. The specific polymer used varies by manufacturer but can be a styrene acrylate copolymer, a polyester resin, a styrene butadiene copolymer, or a few other special polymers. Toner formulations vary from manufacturer to manufacturer and even from machine to machine. Typically formulation, granule size and melting point vary the most. Originally, the particle size of toner averaged 14–16 micrometers or greater. To improve image resolution, particle size was reduced, eventually reaching about 8–10 micrometers for 600 dots per inch resolution. Further reductions in particle size producing further improvements in resolution are being developed through the application of new technologies such as emulsion aggregation. Toner manufacturers maintain a quality control standard for particle size distribution in order to produce a powder suitable for use in their printers. Toner has traditionally been made by compounding the ingredients and creating a slab which was broken or pelletized, then turned into a fine powder with a controlled particle size range by air-jet milling. This process results in toner granules with varying sizes and spherical shapes. To get a finer print, some companies are using a chemical process to grow toner particles from molecular reagents. This results in more uniform size and shapes of toner particles. The smaller, uniform shapes permit more accurate color reproduction and more efficient toner use. Cleanup: toner can be washed off skin and garments with cold water. Hot or warm water softens the toner, causing it to bond in place. Toner fused to skin eventually wears off, or can be partially removed using an abrasive hand cleaner. Toner fused to clothing usually cannot be removed. Toner particles have electrostatic properties by design and can develop static electric charges when they rub against other particles, objects, or the interiors of transport systems and vacuum cleaner hoses. Because of this and a small particle size, toner should not be vacuumed with a conventional home vacuum cleaner. Static discharge from charged toner particles can ignite dust in the vacuum cleaner bag or create a small explosion if sufficient toner is airborne. This may damage the vacuum cleaner or start a fire. Toner particles are so fine that they are poorly filtered by household vacuum cleaner filter bags and can blow through the vacuum motor or into the room. If toner spills into the laser printer, a special type of vacuum cleaner with an electrically conductive hose and a high-efficiency filter may be needed for effective cleaning. These are called electrostatic discharge safe or toner vacuums. Similar HEPA filter-equipped vacuums should be used for cleanup of larger toner spills. Unfused toner is easily cleaned from most water-washable clothing. Because toner is a wax or plastic powder with a low melting temperature, it must be kept cold while cleaning. The washing machine should be filled with cold water before adding the garment. 2 complete wash cycles improves the chances of success. The first may use hand-wash dish detergent. The second may use regular laundry detergent. Residual toner floating in the rinse water of the first cycle will remain in the garment and may cause permanent graying. A clothes dryer or iron should not be used until all toner has been removed. Health risks: as a fine powder, toner can remain suspended in the air for some period, and is considered to have health effects comparable to inert dust. It can be an irritant to people with respiratory conditions such as asthma or bronchitis. Following studies on bacteria in the 1970s that raised concerns about health effects resulting from pyrrole, a contaminant created during manufacture of the carbon black used in black toner, manufacturing processes were changed to eliminate pyrrole from the finished product. Research by the Queensland University of Technology has indicated that some laser printers emit submicrometer particles which have been associated in other environmental studies with respiratory diseases. A study at the University of Rostock has found that the microscopic particles in toner are carcinogenic, similar to asbestos. Several technicians who had been working with printers and copiers on a daily basis were observed for several years. They showed increased lung problems. This confirms previous research published in 2006. Packaging. The toner container can be a simple pack, for toner storage and transportation, or further, a consumable component of the printer. The most common way to consume toner is with a toner cartridge, as an office supply of a laser printers. As a printer's expensive component, it can be refilled. Repackaging. Several toner manufacturers offer toner in wholesale quantities. Typically, bulk loose toner is sold in barrels or 10 kg bags. Toner is then used by a variety of industries in order to provide consumers with a finished laser toner cartridge. Original equipment manufacturers such as HP and Canon as well as manufacturers of compatible toner cartridges use the toner in the process of manufacturing a brand new OEM cartridge. Remanufacturers of toner cartridges use the bulk toner in the process of creating a remanufactured toner cartridge. Other companies use the toner to provide a toner refill service. Most toner cartridges are available to the average consumer through retail outlets or local remanufacturing operations. Remanufactured and refilled toner cartridges are generally offered at a lower cost than original toner cartridges, having been either wholly remanufactured and then refilled with toner or just refilled with toner. Environmental considerations. Recycling of pre-consumer waste toner is practiced by most manufacturers. Classifying toner to the desired size distribution produces off-size rejects, but these become valuable feedstocks for the compounding operation, and are recycled this way. Post-consumer waste toner appears primarily in the cleaning operation of the photoprinting machine. In early printers, as much as 20 to 25% of feed toner would wind up in the cleaner sump and be discarded as waste. Improved printer efficiencies have reduced this waste stream to lower levels, although on average 13% of the toner in each cartridge is still wasted. Some printer designs have attempted to divert this waste toner back into the virgin toner reservoir for direct reuse in the printer. These attempts have met with mixed success. Some consideration and fewer industry attempts have been made to reclaim waste toner by cleaning it and remanufacturing it. Most toner goes to printed pages, a large fraction of which are ultimately recycled in paper recovery and recycling operations. Removal of toner from the pulp is not easy, and toner formulations to ease this step have been reported. Hydrolyzable, water-soluble, and caustic-soluble toner resins have been reported, but do not appear to enjoy widespread application. Most paper recycling facilities mix toner with other waste material, such as inks and resins, into a sludge with no commercial use. In the UK, large compatible ink cartridge manufacturers like JetTech have implemented toner recycling programs in order to receive back empty cartridges for refilling of HP, Lexmark, Dell, etc. cartridges, as no compatible version is readily available. References. External links, Material Safety Data Sheets, HP LaserJet Print Cartridges from Hewlett-Packard, Toner Particles Monitoring Particle Size Distribution and Particle Shape from Malvern Instruments.